Welcome to another session in our Python course. Here we are going to be looking at arithmetic operators in Python. Arithmetic operators are used to perform arithmetic operations, which include addition, subtraction, multiplication, exponential, division, floor division, and modulus. Let us get at it one after the other. So addition, we use plus. For example, let's say x is equals to 5 and then y is equals to 10. So if we say x plus y, then we have 15. So this is how we perform arithmetic operation using the addition in Python. So we use plus. Assuming I want to add again plus 300, you can see now, and so on like that. The same thing goes for subtraction. So let's say y minus x. So we have this. So if we add to it minus 2, we have that. So multiplication, we use the star symbol. So x multiplied by y. So the star symbol, then we have 50. So if you want to add to it, let's say times 10, that gives us 500. Then exponential operator, we use double asterisk sign. So let's say 10 raised to power 2, that will give us 100, isn't it? So if we increase this to 3, that will give us 1,000. Good. So this is how we perform exponential function using Python. Division, we use the backslash. So if you say y by 5 by x, then we have 2. So, and it goes on like that. Floor division is like division, but it doesn't show anything behind the decimal. So assuming we use floor division here, so we use double backslash for floor division. So by x, what do we have? See that we have 2 instead of 2.0. Now let's look at another example. If I say 99 divided by 100 divided by 10, let's use 10. So we have 9.9. Good. Let's use the floor division now. So we have 9. So we see that floor division does not round it up. Rather, it reduces anything behind the decimal. So let's use 9 divided by 10. So it's giving us 0. So that is how the floor division works. So we use floor division when we just want to know the integer component of our output, and we are comfortable with ignoring anything after the decimal. Then we have the modulus. The modulus. The modulus gives us the remainder. So let's look at it. Or let's choose our x and y. So the modulus is the percentage sign. So y, you can see 5. So What does this mean? Let's go back to x divided by y. So you see that this is 0.5. So the modulus gives us remainder. I think let me use another example. 10 divided by 3, isn't it? Now, if I use modulus here, we have 1. So because when we divide 10 by 3, it is the remainder is 1. So the modulus gives us the remainder. So let's use 8. 8. So we have 2. So that is what the modulus does. Good. So this code here is used to show us the values that are even number between 1 and 10. So between 1 and 10. And you can see that we are saying that for anything between 1 and 10, if the integer divided by 2 using modulus is equal 0, because the point is that any even number, when we divide it by 2, the remainder must be 0. So if you get any value between 1 and 10, you divide it by 2 and the remainder is 0, give us those values because those are our even numbers. You can see now. But if I say equal 1, I'm saying that when you divide any integer between 1 and 9 by 1, by 2 rather, the remainder must be equals to 1, and that will only qualify for our odd numbers. So let's see what we have. You can see now these are our odd numbers. So this is just a simple way of letting us see how we can integrate modulus into a bigger code. Let's talk about orders of arithmetic operations. So if we have bracket, the bracket, anything inside the bracket is performed first. So like here now, you can see this syntax. It means that Python will first of all undo everything inside the bracket. The next is exponential, followed by multiplication and all the other ones. So if you see this now, we have x is equals to 20 plus 22 minus 4 divided by 2 plus this. So Python is going to undo this first, and if we do it by ourselves, let's say we start from here, a times b, that is 10 times 2, that should be 20. So let's see. Then we have 4 divided by 2, which is 20. And then we now have other values. This is 20 plus 22. So this will be minus. So we have a times b, which is 20. We have plus here. We have minus 40 divided by 2, which is 20 minus 20. And then we have this. So, and this gives us 42. So if you run these two, it should give us the same thing. You see now, it gives us the same value. So that is very, very important, because when you want to perform an arithmetic operation with Python and you want to arrange your values, you must arrange them keeping all of these in mind. Good. Let's talk about comparison operators in Python. So we have equals to, which is usually performed using double equal sign, less than, greater than, less than or equals to, greater than or equal to, or not equals to. So let's look at them one after the other. So let's say we have 4 less than 5. So if I say this, you see now it's true. 4 is less than 5, so it's true. But if I change it to greater than, so it's false. 4 is not greater than 5. So what if I use equal? So you see now 4 is equal to 5. So this equal. So now the same thing goes for less than and greater than, like I have explained in this place. Now let's look at greater than, less than or equals to. So if I say y is equals to 10, x is equals to 5, and I say x is less than, or let's say x is less than or equals to y. So if you look at this, x is less than y, but it is not equals to y. So it's going to give us true value because of the or in between. So it's less than, as long as one of the conditions are true, it's going to give us true for it. Now let me give another example.
Okay.
X is greater than or equals to y. X is not greater than y because y is greater, and at the same time x is not equals to y. You understand now? So both conditions are false. So x is not greater than y, and at the same time x is not equals to y. So this will give us false. So, and the same thing go for greater than or equals to. So if we say 50, let's say 50 greater than or equals to 40. So it's going to give us true, because even though 50 is not equals to 40, it is greater than 40. However, if you put 100 here, so 50 is not greater than 100, but and it is not equals to 100. So both conditions are wrong. It's going to give us false. So let's see. But if I put 50 here, so 50 is not greater than 50, but 50 is equals to 50. Hence, it's going to give us true. So that is how it works. Now, let's talk about not equals to. So x is equals to 5. So if I put this that, if I put it that x is not equals to 5, so this symbol here is not equal. So it's going to give us false because x is equals to 5. So saying that it is not equals to 5 is false. So you can see now. So let's say we have x is equals to 10 and y is equals to 5. So x is not equals to y. So that also will be true because x is not equals to y. So x is 10, y is 5. So this is how comparison operators and the arithmetic operators work in Python. We are going to be doing a minor project very soon, and we are going to be applying all of these in that project. So we should try and practice all of these by ourselves using different methods. I'm going to be giving us these notebooks at the description below, so you can download this notebook and also do some manipulations and play around some of these things. It is very, very important. Until we meet in the next one, please do not forget to subscribe to our channel and like our videos. Thank you very much.